Yeah. So now secondary name node. So somebody just asked me like what happens to the secondary name node. So secondary name node can still be used, but it's the if you really see in the high availability architecture, the secondary name node has not a major role to play, right? Because we have, if you look over here, we have this information getting stored in a journal node, but still this is an option in Hadoop 2. We can still have a secondary name node and it will serve the same thing. So it will also keep a backup of FS image and the edits log. That's an option, but usually if it's always good design to have it in the cluster, so we have a backup somewhere else as well, right? Not only these but somewhere else as well. So that can also be done. It will continue doing the same thing, like maintaining the edit log and the FS image file. And then master will have the metadata, data nodes will have the data blocks. All right, now how does HDFS looks like? So it's similar to Linux file system, right? So everything starts with a root, and which is represented with a slash, and then we can have one directory. Within the directory we can have multiple directories and then the file. So it's just a hierarchy structure like our Linux file system. Similar to that we have in the HDFS also. And all those operations that we do in a Linux, like create a directory, create a file, move, rename, delete, all of those things, all of that can be done with the HDFS file system as well. Okay, so all those operations are supported. Okay, so how does a name node work? So like as we discuss, any changes. So while starting, so the first step is it will retrieve, it will load the FS image on the RAM, and then it will read the edit log also. So both of these things, it will when it gets started, it will read both these files. So FS image, edits log, both it will read, and it will update everything in the RAM, and then it will keep on serving, right? And any changes which happens, then those will be again recorded back to the edit logs. That's how the name node operation works. Right, so how exactly are we splitting the file? So if I have a bigger file, let's say I have a file of 500 MB. So can you tell me how many blocks it will have? I have a file of 500
4.
MB.
500 divided by 128.
500
It will
divided
be
by
4.
128, that will be ideally 4 blocks, right? So 4 blocks. So the way it will work is like all the each of the block, just take and then put them on the data nodes. Right? So let's say block 1, block 2, block 3, block 4, just distribute them on the data. And then the name node will be, this name node is responsible to maintain like which one went where, right? So I splitted this into 4 blocks which got distributed, but I also need to know which one is present over here, right? So which data node contains what block. So all that will be maintained in the name node. And one thing very interesting about this architecture is all these data nodes, they are in a continuous communication with the name node, right? So anything which is happening to the file system, and in a periodic way they are sending the block report. So each of them, like data node 1, 2, 3, everyone is responsible to send a report of the blocks to the name node, and name node will get all that report, and it will keep updating, okay, how many of the data nodes are alive, what is the status of each of the block which they contain, right? So there's a continuous heartbeat communication which happens between name node and the data nodes. Okay, now we have
Dheeraj, I have a question.
yes,
As you said, like 500 MB, and we have divided by 128, and it's 4 block. So some if data is exceeding 500 MB, so exceeded data, how it means, how it is identifying, means how it is flowing in which node.
okay, very good. So see, usually what happens if, let's say I have file, right? And it is in the 4 blocks now. Now if the size of this file, if it increases and it became, let's say, 600, so the fifth block will be created, and then that entry will go to the name node. Name node will record it, saying for this file I have one more block, and it will record the location where it is storing.
Okay, thank you.
Okay, so let's take a scenario. We have a quiz. So what it is saying is, let's say, suppose we have a scenario where we have a file which is distributed to the HDFS cluster. Okay, now the same thing that we discussed. So let's assume they are divided into 4 blocks: block 1, block 2, block 3, and block 4. And then data from each block is sent to data node A, data node B, data node C, and data node D respectively. Right, just like this. So we had a file, 4 blocks: block 1, block 2, block 3, and block 4. And then each of the block went to node number A, B, C, and D. Okay. Now data node A crashed and block 1 will be lost, right? So if this one is crashing, then definitely the blocks stored will become unreachable and it will be lost, right? So what ensure that the data is not lost even if the data node crashes? Is it the name node replication or it's the block replication? Who ensures that my data is not lost?
Block replication.
Block replication, right? Because name node has nothing to do over here. It's only the block. Since I have replicated my blocks across multiple nodes, so this ensures my data is not getting lost. Very good. Okay. Now, one thing very interesting about block replication is HDFS tries to have the best possible way to ensure even if some of the node crashes, we are not losing the data. Now, if you look into this architecture, let's say we have 2 racks. Okay, 2 racks, right? Rack 1, rack 2 we discussed over here, right? We have 2 racks. One is having 5 nodes and rack 2 is having another 5 nodes, so total 10 node cluster. Now over here, name node is submitting some of the jobs. So let's say name node is submitting some job through the job tracker. It went to this rack, and over here we have rack 1, node 1, node 2. Some 8 nodes are there in this rack, and due to some server error, this entire rack is down. Okay, now if you really look, there is a rack 1 node 4, and there is some block present in this. So the same block 1, we have a replica across the rack as well, right? So it's not like all the copies are present in one rack. The copies are scattered across different racks, so that if in case of any network issue, there is the chances of not retrieving the data, or chances of data lost is minimized, because it might not happen like both the racks are failed at the same time, right? So since we have another rack healthy, so the request can be served by this one as well. Okay, so that's how HDFS ensures that replicas are properly scattered across different rack. Okay, and okay, so now there is something which is known as, okay, yeah, sure. So Manoj has some doubt. Okay, can anybody explain me like what exactly this mean? Anybody who wants to volunteer and say like how does it ensures no data failure in case of a rack failure? No data loss in case of a rack failure. Anyone?
I think it follows a algorithm here, rack awareness algorithm, to store the replicas.
Okay, so what does that algorithm says?
It gets the address of all the racks present in the cluster using a JavaScript or something,
Okay,
and then it tries to store the replicas on the different rack.
very good. So what, that's a rack awareness, right? So what this name node will do, it will find out how many racks are present in my cluster. So the moment it comes to know, like we have two racks, rack 1 and rack 2, and it knows like rack 1 has node number 1, rack 1 has node number 2, node number 3, till node number 8 is present in rack 1, and another node, another list of nodes are present in, let's say, rack number 2, right? So while doing this, if some of the rack 5, let's say this rack is, so while putting up a copy, what it will do is it will put a copy in rack 1, some node of rack 1, and some another copy will go into rack 2 as well, right? Because name node's responsibility is to replicate the data. So which data will go on which nodes, what is the list of the nodes, that is all handled by the name node. So I'll show you over here if you really see. So the way the replication happens is each file will be split into a sequence of the blocks, right? Which is nothing but 128 MB chunks of the data. Okay. So first 128 become block number 1, the second 128 MB of the file will become block number 2. So in a sequence it will be put, right? Except the last one, all the blocks are of the same size, right? Except the last one, because last one is nothing but the remaining one, right? So in this 500 divided by 128, we said 4 blocks. So first 3 will be 128, and the fourth one is whatever is left over will become the fourth block. Okay. Now the way the replica happens is like first it will create name node. So whenever any, while storing the data, let's say I have some file with the name of data 0, right? And the replication factor is set as 2, right? So it means like this particular file is, let's say this is split into two of the blocks, block number 1 and 4. So first it will try to store in some of the data node and any one particular data node, and then it will, the name node will call out another data node also, and it will say, okay, you are responsible to replicate the data, right? And the another data node will go and it will replicate the data. Similarly it does for the second file also. It will appoint some of the data nodes, okay, you go and store this particular block, and some another data node to replicate the data as well. So like this, the whenever client writes a data, it will go to a particular node, and the replica will be automatically done by the another data node.